Hello, I'm going to walk you through how to deploy a driverless AI MOJO scoring pipeline within a Flink data pipeline. Or you can think of it as a Flink ETL pipeline or a Flink data flow. Here I have my fork repository from H2O AI DAI deployment examples, and on this particular README are the steps where you can go and do this deployment example. I'll be walking you through how to do it. So first, we need to launch an EC2 instance. We'll be doing Ubuntu 18.04, T2 2x large, .56 gigs. Okay, and we're going to add a TCP port for 8081. We're going to have source be default, and then this is for review, and looks good. We'll launch. We'll choose the existing key pair EC2 model deployment. Alternatively, you could create a key pair if you don't already have one. Then we'll go to our instance. It's currently initializing. We're going to get the public DNS. Clear that. Alright, and we're going to update our bash profile since we're on the Mac. Okay, and this line here, H2O DAI scoring instance, has an old public DNS. We just need to update it. And then below you can see is the PEM key. Okay, save it. We're on source on bash profile. Okay, now it's been executed and our environment variable's been updated. So now we have our EC2 instance. We also have an existing key pair, so this first step's already been done. We just updated our EC2 public DNS in the bash profile. Alternatively, for Linux, you would do it in the profile. Alright, and now we're going to SSH into our EC2 instance. Type yes. And then we're going to create this environment directory structure, DaiMojo Flink, and a test data directory with test batch data and test real-time data directories inside that. And then now we're setting up driverless AI MOJO requirements in EC2. So the first step here is for users who haven't built their driverless AI experiment yet. They can walk through these steps here. The second one is once you've launched your driverless AI experiment, there's a button called Download MOJO Scoring Pipeline. You just have to click it. It'll download the mojo.zip to your computer. Most likely it'll be downloaded to the downloads folder. And then we get to this next step where we're going to use the scp command to transmit that mojo.zip to our EC2 instance. So since our mojo.zip is in a different directory than downloads, we'll go to that particular directory. So we're going to go to DaiMojo Flink, and then I have it set up in a way where I have a driverless AI 1.8.7.1. So I was using that particular driverless AI version when I built the experiment, and inside there we can find the mojo.zip. So we're just going to take this portion of the command, then mojo.zip, and we're going to take this other part of the command, just like that. We're going to send it over. Okay, and then on the EC2 instance side, we're going to get ready to unzip the mojo.zip. We'll install unzip. Okay, and we're still waiting on this to finish. Once it finishes, we'll then unzip the mojo.zip on our EC2. We finished sending our mojo.zip to our EC2 instance. Now we're going to unzip the mojo. So let's go into DaiMojo folder, and then let's do an unzip. Okay, and we can now download Anaconda. And next we'll install it. Reading through the agreement, just scrolling through it because I've read through it before. Okay, and then type yes, click enter. Now Anaconda is installing. Okay, and we're going to type yes for conda init to initialize it. We'll exit from EC2, SSH back in. Now Anaconda is installed. Let's create the model deployment, conda environment. Okay, and then we're going to activate the environment, meaning we're going to go into it. And then we're going to install OpenJDK version 8. Then Maven. Okay, and now what we're going to do is we need to set our driverless AI license key as a temporary environment variable. And so we just have to copy a portion of the command into the terminal. Then we're going to get our driverless AI license key, copy and paste it in between the double quotes, and then click enter and continue. Okay, so in this right terminal here, I just copy and pasted in my driverless AI license key between the double quotes. I clicked enter and then I cleared the screen. You typically don't want to show your license key, but it's usable in the shell session. So if we exit from this shell session, we'll just have to set our driverless AI license key as a temporary environment variable again. Alright, and next what we're going to do is we're going to download Flink. Okay, next we're extracting Flink. Alright, and then we're going to cdn. We're going to start our Flink server. We're going to start our Flink cluster. Alright, and to access it, let's get our public DNS, followed by :8081. That's why we opened the custom TCP port for 8081. And here's Flink. We'll keep it running. Next, we're going to do some data preparation. So we're going to go to the MOJO pipeline folder, and then we're going to copy the example.csv to test batch data. Now we're going to go to the test real-time data. We're going to perform a split operation on the example.csv, which we'll copy over to this directory. First, we'll remove the first line. In the CSV file, usually the first line is a header, and in our case, this CSV first line does include a header. Alright, and then we're going to split the file into multiple files, each containing one row of data. All right, and then we're going to add the .csv extension. The reason I'm doing it like this is to account for Mac. So Mac's split command is a bit limited compared to Linux's split command. With Linux, there are more arguments that you can pass to this command here, but I wanted to write the script or the commands in a way that would also account for Mac as well, in case someone wanted to run this example on their Mac. Okay, and next what we're going to do, we're going to cd back to home, and then we're going to clone DaiDeployment examples repo. So I do a cd, you could do cd home alternatively, and we're cloning from the MOJO Flink branch. Okay, and then we're going to cd to the DaiMojo Flink data pipeline project. We're going to run maven clean install. Alright, and while that compiles the project, I'll just explain this command first. So with Flink cluster, we can run Flink run, and we can specify the main class manually. So we're specifying that the main class is, if we look along this path here, we get to the Java package classify hydraulic cool condition, and then there's a class in there called batch predict hydraulic cool condition, and we're getting that class from this jar package. So first we're going to run batch scoring, and what this does is it executes the driverless AI MOJO scoring pipeline on the example.csv to get batch scores. Alright, and as you can see, nothing is on the screen yet, so we're going to run this command. What this does, Flink run, it submits the batch predict hydraulic cool condition Flink job for execution on the local Flink cluster, or actually in this case on the EC2 Flink cluster. And Flink's job manager runs this job here. And so we see deploy DaiMojo SP within a Flink batch ETL pipeline. Here's our data pipeline. We have a data source, so it's called get predicted labels from MOJO. We can actually get the predicted header or column names from the MOJO scoring pipeline. It already knows it ahead of time. And then this component here, which is actually, it's calling on multiple Flink functions. First we start with our Flink data source. So we're pulling in data using Flink's read text file. I'll show you the code in a bit. And we're getting batch data from the test batch data directory. And then the next Flink function is we're running a filter to filter out the header, because our CSV file has a header in it. And then after that, we're going to perform a map function. So what the map is doing is it's executing the driverless AI MOJO scoring pipeline to do batch scoring. And that is, we're taking input data, it's a CSV data, and it's a string, and then we're performing the predictions on each row of the CSV, and then we're outputting the predictions, and we're storing them back into a CSV string that includes the predictions, and then we're transmitting that data to the data sync. And then what happens is we have two of these data sets that are created, one that has the predicted header and the other that has the batch scores, or the batch predictions. when they meet at the data sync before the data sync is executed to print the predictions to standard output, there is actually a Flink union operation that's done, and that's to put the predicted header as the first row, and then add on all the predictions below that. So then what happens is when we click this, we click Task Managers, we then click Log. So here what's going to be loading is the logs, and the logs help us to debug our program when something doesn't go well. And it can just tell us about the program, how it executed on the Flink cluster. And then we have standard output. So this is standard output to the task manager. We can see here this particular row is our prediction header. We can ignore the warnings here. And then we have our batch scores. So think back to the example.csv. It was a file that had multiple rows in it, and we executed the Driverless AI MOJO scoring pipeline to do batch scoring on that. And it's taking a chunk of data, it's performing predictions on that chunk of data, and then outputting the chunk of predictions. And we get them printed out here. Now, the other approach that we could do that I'm going to show you guys is we can deploy the Driverless AI MOJO scoring pipeline within a Flink streaming pipeline. So that'll be what I show you next. So let's stop the cluster. We'll just restart it. Here, we're going to go to the Flink folder, do a stop cluster.sh, okay, and then we'll start it up again. Okay, so that should be on. Open up 8081. Okay, so earlier what we showed you was batch scoring. Now we're going to show you real-time scoring. And so all we need to do, we could run all of this command here, right? And that's specifically telling the Flink cluster's job manager, we want you to execute the real-time prediction hydraulic cool condition job. Alternatively, though, in our Flink project, we can specify in our POM file the main class. So then when we say Flink run followed by the path to the jar package, the Flink's job manager, from reading that POM file, will know what is the main class to execute. So we're just going to we're going to copy in this portion of the command. So we have Flink run, and then we'll skip this -c argument, and we'll just copy in the path to the jar package. Okay, and what we're going to see here is the job that's going to run in the complete will be the stream processing job. So there you see it's running. There you see it finished. We deployed Driverless AI MOJO SP within a Flink streaming data pipeline. And here's our data pipeline. So we pull in the real-time data. So again, that was just how earlier we took the example.csv, we split it up into multiple files, each containing one row of data that are in that test real-time data directory, and then they get moved to it's a MOJOTransform function. I also use this MOJOTransform function in the batch scoring example. It can be used here too. So what it's doing is it's executing the Driverless AI MOJO scoring pipeline to do real-time scoring on these individual rows of data that are in each individual file. And the predictions, the real-time predictions get transmitted to the data sink. And similar to the last data flow, data pipeline, is we have this, we're getting the predicted labels from the MOJO scoring pipeline. And then at this data sink, we also have a union that's combining them. So what we see, I'll show you this here, these are the names of the components. But what we see for the predictions, we click Task Managers, Log, go to Standard Out. We can see there's our predicted header and then each individual real-time score. So difference with this is real-time scoring is making a prediction on an individual row of data and then transmitting it, whereas batch scoring is making predictions on a batch of data and transmitting the batch predictions. So that's how you do batch scoring and real-time scoring when deploying the Driverless AI MOJO scoring pipeline in a Flink job. So let's look at the code. So we'll start with the batch scoring example. And so with Flink, it's kind of similar to NiFi when it comes to the idea of building data flows, data pipelines, except instead of doing it in a visual canvas where you can just drag and drop processors, you're building out your data flow programmatically. So we have a class called batch predict hydraulic cool condition. Similar to NiFi, you would have, once you save your data flow, you have a NiFi template. So in this case, this is sort of like our NiFi template, but in the case of Flink, it's our Flink data flow. And then we have our main, and this is where we're going to start adding different components to our Flink data flow. So first, the first part is to instantiate an execution environment variable, and we call that environment. And then we can use that, it's like a controller, we can use that to pull in data. So on the environment variable, we call its method read text file, and we pull in that data, store it into a data set of string elements. And then we have our filter, and we have this hydraulic data set string elements that we're then calling filter to perform filter on it, and we have filter header. So we're filtering the header, and then we're passing in this config. The config contains this parameter, skip first line header, and it's set to true. And we're just passing that to the filter. And then we have this map function, and this is where we're actually executing the MOJO scoring pipeline. So we're passing in the file path to the pipeline.mojo, and this here is just in case you wanted to use the logger and associate it with the class that we have the data flow in. So what we get back after running this map function is a data set with hydraulic predictions, and then we get the MOJO frame meta that has our predicted. So it's getting the prediction MOJO frame metadata. So this is where we're going to be getting our predicted column names, where we're going to be creating our predicted header. So we just use arrays to string function, and then what's happening here is on that predicted MOJO frame meta, we're running the get column names to create a string array, and then we're converting the string array to just a string. So we have a string of predicted for the predicted header, and then we're just doing some further processing to remove the brackets and the white space. So then we just have comma separated values that are a string for the predicted header. And then what you see here is the union. So the union is the union between the predicted header. So it's a union between the hydraulic predictions and the hydraulic predicted labels. So the labels go on top, and then the hydraulic predictions go after it. And then we print the batch scores on the task manager's standard output, and then we try to execute the Flink data flow. Things go well, then it executes fine, else it catches an exception, and for more specific exceptions, we throw a job execution exception. So that just is to let us know that somewhere when the Flink job was executing, it failed. Alright, alternatively, we can create a Flink real-time streaming pipeline. And this is similar. Up here, again, that I did similar in the batch scoring pipeline example. We load the MOJO scoring pipeline, but that's for helping us to create the predicted header. We read from a directory that has all the files, so all the files that were split up. So we get a data stream instead of a data set, a data stream called hydraulic that has string elements. So those are just, you can think of them as individual, each data stream has an individual row of data instead of a batch of data. And then we call on map to use MOJOTransform to execute the MOJO scoring pipeline to do real-time scoring. So we're taking the data stream, each row from the data stream, and we're performing real-time scoring on it to get hydraulic cooling condition. Now, the difference here is instead of taking a batch of data and then performing the predictions on that, we're taking a file that has one individual row of data, and we're performing real-time prediction on it. So each individual file is getting passed into this map function, and out is coming the prediction on that individual file. That individual file that has an individual row of data. And then we, again, construct our predicted header, we perform the union, we print out our predictions to standard output on the task manager, and we execute the program. MOJOTransform. So this is our custom RichMapFunction. So Flink has a RichMapFunction that we can further, it's a user-defined function, and we're calling this MOJOTransform. So the MOJOTransform inherits from Flink's RichMapFunction, and we pass in to the constructor the pipeline MOJO file path. And then before the function starts executing, doing the actual work, the very first time that this function gets called, we load in the MOJO scoring pipeline, and we get the input metadata. And then we perform these operations. So we do a string to MOJO frame conversion, we perform predictions on the MOJO frame, the input MOJO frame, and then we convert the MOJO frame back to string. So here we can see we're using the MOJO frame builder, MOJO row builder, and we're then using a string reader on this input data, which is a string. And what we're doing is we're reading that string similar to how we read a file into a CSV reader, so then we can use the CSV reader to parse through that line of CSV data. So these are real-time, this is real-time data you can think of, and we're just taking that one individual line, because each file has one line, and we're creating a new row out of that line. So we are creating the row using key value pairs. So once we're finished getting all the fields and constructing, setting the values for that line, then we add that row to the frame builder and we return the input Mojo frame, and then next we run the prediction, and then we return the prediction, and then we just have to convert the Mojo frame to a string. So we create a one-dimensional string, and there's only ever going to be one row. So we're just looping through for that one row all of the column entries. So these are just the data fields, and we're constructing, we're adding each of these data fields into our one-dimensional data string. And then we're using string builder to take our string array and convert it over to just a string, and then we're returning that. And that is the Flink data flow, and that class, that function, is being used in both the real-time and batch processing Flink data flows. With one more addition to the batch processing Flink data flow, we're using a filter header. So the filter header is just for the case where we want to remove the header row, or you can think of it as ignoring the header row. So what happens here, we briefly mentioned with the configuration, we specify whether skip first line header is true or false. We know that our CSV example.csv file has a header, so we're going to skip it. And in the header, we pass the config. So we're actually in the open method of this filter header. We're getting the key called skip first line header. We're getting that Boolean value, storing it into the config option object here, and then we're passing that into get Boolean to get the keys value. We're getting skip first line header Boolean value. And then in our filter method, what this does is it's going to filter out that header, the header from the CSV file. And then once skip header condition's true and we go in there, we're going to set that to false. Whenever this filter method returns false, what happens is it tells Flink to ignore that line of data. Right? If it returns true, then what's going to happen is filter is going to not ignore that line of data. So the idea, we just want to include all the data except for the header from our example.csv. So this filter header is being used in our batch processing Flink data flow. So congratulations, you just learned how to do Flink batch processing and Flink real-time processing while integrating the driverless AI Mojo scoring pipeline.